Why? Okay, hold on. Focus on in. Wherever you were, you did have time to talk in your groups, but now it's time to focus back on that. I asked just a second ago, the first thing that you did, I heard quotient property. And then I asked why. Let me hear the answers to why again, just because it was all scattered and people were chatty. Why? Why quotient property? Good, that's one. There's a subtraction. Good, Tyler. There might be another reason, though. Why quotient property? Because then you can take the two logarithms and get them together to 1. That's actually very helpful. We'll see why in a second. And even more than that, I would say because there are x's in 2 spots. So the reason it's important to get it all together in 1 is because I have x's in 2 spots, and somehow I need to bring those x's together. And with logarithms, we can do it if there's a subtraction by the quotient property. Now hold on. Some of you guys got stuck at this next step, and that's okay. Let's talk it through. The logarithms in 2 spots became 1 was perfect because not only do we have x's kind of together now, but also the logarithm is in 1 spot. In section 3, we're using our skills of exponential and logarithms to do things like get to x's inside logarithms using what property? Inverse property. How do you get out or take away or undo a logarithm? Find the base and raise both sides to that power. We're putting in the inverse operation. If there was a squared, we put in a square root. If there was a cube, we put in a cubed root. If there was a minus, but there's a logarithm base 4, so we need 4 to the power of. So what happens here? Cancels. Reduces, undoes. I heard a few of you guys struggling here. How do we do 4 to the 1/2? Why is it 2, though? Because you might be doing it the wrong way. It's a square root. If you just cut it in half, you're wrong, because 9 to the 1/2 is not 4.5. 9 to the 1/2 is 3. Square root, yeah? 1/2 power is square root. The little 1 stands for the power inside. The little 2, the half, stands for what kind of root it is. Now, once I have this equal to 2, Jordan, is that good?
Yeah.
Okay. I thought, yeah.
In my head, I did it different. I didn't get to do it.
Yeah, that's what I figured. Yeah. And I was afraid that if it had been in like a 9, people would have. Yeah. But now square root. Got it. Okay, how do we get rid of? What do we get next? Yeah, if someone tried canceling out x's, you're killing poor little kittens. Don't do that. But we can multiply. That's legal. What am I going to do in this next step? Don't kill a seal. And then we're just combining like terms, right? Who got 2? My equals kind of was disturbing. Let's get rid of that. But subtract 2x. Divide or multiply both sides by a negative. X equals 2. Who got it? Give me a thumbs up. Okay. Okay. Those that didn't, or even those that did, do we need any clarification? Those that got it or those that didn't? Do we need any clarification? So why was it helpful to use the quotient property once again? Single logarithm. X is in 1 spot. And how can we get rid of any logarithms with bases? Raised to the power of both sides. Yeah? Then it was algebra after that. What are we doing in section 3.4? We're taking all the tools from 3.1, 3.2, 3.3, and we're putting them together to get to x. That might mean using properties from 3.3, and sometimes that might mean using the whole inverse 1-to-1 idea from section 3.2, and sometimes that might mean just using algebra from algebra. Jordan.
So when you're saying raising to the power of whatever this one is for, like I know what you're doing, and I know that like you have to do to both sides, and then everything the log will cancel out.
Yeah.
But I don't know what you mean. Is it like you're putting it as an exponent?
Yes. So I'm putting the little caret because sometimes, like especially if you're in your homework spiral, It's probably hard to like, because this is and show that to the indicating like it would in your calculator to the power of. So yeah, this whole entire left side becomes the exponent 4 to the power. And so this would be rewritten, technically, if it helps a little bit, as 4 to the 1/2, which is square root of 4, which is why I was able to go down to 2. So this will square root. Oh, no. The caret, like if you were to do it in your calculator, you hit number and then caret, it's that number's exponent. So the caret just bumps it up. 1/2 to that would be like 1/16. Ugh, gross. Yeah, so when I'm doing 4 to the power of, it's literally like a 4 with the log base 4 of x over x minus 1 equals 4 to the 1/2. Okay. All right, guys, let's go back to our notes. We only have a few more examples to do, honestly, before we're totally done with 3.4, and that was one of the hard ones. Maybe medium in context of the whole chapter, but hard for this section. So let's go back to the one that we ended with. Ooh, that's a that's a hard one too. Let's go back to this one, number 35. Let's go ahead and keep with the back of the homework spiral being a medium level. I like that. If that back one is a medium level, hopefully most of you now are like, it's possible. Yeah, my brain might not have done it, but I haven't mastered this section yet. I still need to do the homework. I still need to like go over the ones I get stuck on. I still need to do a review on it and then study it. You're probably in some ways still a long way from mastery, hopefully closer than you were when you came into the class this year, but we haven't mastered this section yet. Eventually, hopefully, the one that you just did will be a medium level, maybe even like an easy medium in between. This one is a hard. This one's a hard. I started him at the end of yesterday, but there just wasn't time, and I was like, oh, duh, we have a whole nother day for this section. We're okay. We're going to get into 3.5 just a little bit, but we have time. So we're going to go together on number 35. Step by step, okay? So the very first thing, which is what I got to write down yesterday at the very end, the very first thing is to realize that it's hard because of what? What do you guys think? Why is it hard? Yeah, 2 and 3. I'm hearing 2 and 3, 2 and 3, different. I have 2 exponential bases. They have different bases. So I can't just do what I did over here and say, oh, hey, log base 3 of both sides. Wait a minute, hold on, pause. We didn't even finish this guy. But is this guy easier than that guy? Not really. Are you sure? What happens after we 3 of both sides? What happens here? They undo each other, and you get just 6 minus x, right? Equals log base 3 of 5. How do we solve for x? Okay, so let's move something. What should we move first, the negative or the 6? Yeah, so let's just subtract 6. You don't like it, maybe, but whatever, I have to subtract 6. Maybe some of you would rewrite it negative 6 plus log base 3 of 5. You're my hero, but either way, you're right. But what's on this side now? I'm so close to being done. Last step is just to multiply or divide, either way. By a negative 1, you get x is equal to, would you guys have switched both the signs? Careful. Would you have switched both the signs? Multiplying by a negative, dividing by a negative, you have to divide or multiply everything. So sign flips, sign flips, sign flips. Now, there are different forms. We talked about this just briefly yesterday. But the algebra, guys, was pretty basic as far as, well, first of all, the exponential log skill of having a 3 to the power of and needing to undo it. We had to put in, you will have to put in the logarithm to say, oh, I know what undoes it. But what you do to one side, like Jordan said, you must do to the, So this one cancels out. The other one is stuck, but that's okay. I can plug that in my calculator. Why am I saying plug into the calculator? Remember what they're having you do in homework? Why go to decimals? Because this could have been written like that, or this could have been written like this, or this could have been written like, oops, minus, not equals. That won't make sense. Now, if you notice, it's starting to look kind of similar because I'm just changing which logarithm I'm changing the base to. But there were technically, hi, who are you? Go away. I hit that button and it popped up. All of these, guess what would happen if you put all of them into your calculator? You get the exact same decimal as the back of the book, and you can be like, check, done, got it, no problem. Okay? But this one, the algebra was pretty straightforward. Subtract the 6, divide by negative, done. This one, well, first of all, we can't just do one logarithm to get rid of both bases because, as you guys, a lot of you said, the bases are different. So did I even use a log 2? Base 2? No. Did I use a log base 3? No. Why? Because I've done a lot of math, and LNs end up to be a lot nicer. So since LNs are more like my friends, I'm like, let's use you and let's not use you. Okay? But could you have used a log base 2? Sure. Could you have used a log base 3? Sure. But either way, you're going to get stuck because somehow it's not matching and the power has to come down. Now pause real quick. Stand up. Give everybody in your group a high five. You have people already falling asleep. And you were so cold at the beginning. I thought you would like it warm. Stand up. Literally, stand up. Give everyone in your group a high five. We have people falling asleep. Twirl around 2 times, then sit down. Okay, the twirl is optional, but either way, here we go. Drink your water, Lauren. Drink your water. Drink more. She volunteered. I didn't point anybody out. All right, go. Now she's awake. Okay, here we go. Question. Are powers always allowed to come down if there's a log? Yes or no? Yes. Yes, it's called the power property, right? So I power down. There are my x's. Yay! But on Precalc, just took a test on this, chapter 3. I heard one kid who usually does pretty well be like, ugh, I got stuck on this long answer. I'm not saying. They got stuck on a problem, on a long answer. A problem I warned them about very specifically from this section. And guess why it was hard? Something to kind of do with this. Kind of. Not perfectly, not exactly, but kind of. What makes this hard made it hard, but there were 2 things that make this hard. I won't tell you which one's which. Anyway, plus your tests are a little different. But coming back. What makes this hard is different bases, but we've already done an x. Hey, there's an x. The other thing that makes it hard is this guy. How do I get my x's together?
You can divide.
Nope, don't divide. Bad idea.
No, not divide x.
Oh. What are you going to divide?
Take it from one side for the other side.
Okay, I mean, we can divide the ln too if you really want. How do we get the x's on the same side, though? Okay. Hopefully no one's writing this down. Now what? Exactly. But that's okay. That's why it's hard. Yeah, shoot. Now what? Well, cross it out and kill a kitten and just be done? And there's no x anywhere in the problem? No, that's a bad idea. Cross multiply. That gets us right back to where Joe was. Matthew was like, why don't we cross multiply? Okay. My little rebels that want to do all this illegal stuff, stop. We'll go into life lessons later about that. For right now, we want to solve the problem correctly. Jordan.
When you put the ln in at the first page,
Mm-hmm.
so you can just like pull that out of thin air.
Yeah, remember I said from my future training, I figured out that ln is a much nicer guy in all reality with him. So I tend to, if I have to choose a log, I'll always go to him. And the reason why I'm choosing a log is because he had to make a choice somehow. Could you have done a log base 2? But if you had done a log base 2, this one would have had to power down anyway, and you would have had basically the same dilemma. You would have had basically the same dilemma. So I'm showing it with an ln because I'm just trying to teach you guys ln not as scary as you think he is. He actually ends up being way more useful in so many like science, physics applications. He comes up a lot. So I'm just trying to, number one, get you used to him, and number two, how to solve this problem. Matthew. Over a power of what? Well, here's the problem. I like what you're trying to say. The only problem is as soon as you put in an E, I can't get straight to the ln because of him. So what I could do to make it legal and get to the ln is I could put the x up as a power, and then the E and ln will work. And I could put this up as a power, and then the E and ln will work. Hold on, Joe had an idea. Joe, what's your idea? Or did you still have an idea? Did you have an idea? Next. That doesn't work. Okay, you ready? Pause. I want you guys to think of something real quick. If I was to change just one little thing, and this isn't the same problem, but if I was to change one thing, what would you do? If I was to change this, representing a constant, if I was to make this, and if I was to make this B. Now, some of you guys are like, no, 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 that didn't help anything. Joe, hand down. Stop. Let people think. But we'll see in a second. No, no, no. Stop, stop, stop. But we'll see in a second if he was right, because he very well might be. Hold on. We'll make this an A. We'll make this a B. Now, some of you are still like, that didn't help. But what if I was, I know, that's good. But hold on. I'm teaching to a whole class, not just one or two. For sake of argument, A is a constant. Someone give me a constant that's pretty, not this nasty ln of 2. Give me a pretty constant. 1. Well, something better. No, let's do 2. And then something else, another constant. Okay. Okay, pause. Stop arguing about the constants. This is really an A and this is really a B, right? Pause. Pause. What math would you do to get x alone? Well, it's kind of like the past one-to-one part. We're now to the algebra. Divide! Why are we dividing? You can't subtract. Thank you. I know, right? It's so easy. You just distribute. And what's the point? I know, it's written weird, right? But couldn't we just get the x's together, right? It's so big. And then you just get negative 1x equals 3. And then x equals negative 3, right? Okay, now I'm just not writing. But you guys knew what to do. Pause. Pause. It works better when the number is prettier, but that's still just a number. So check it. What are we supposed to do? Got rid of them to see if you guys could understand the math I was about to do. If there were pretty numbers in those spots, you guys eventually, a little longer than I thought, got to distributing. Eventually. I heard someone back there say distribute. I know you want to divide, subtract, and it's kind of silly because it makes everything bad. Like you can't minus anything. Anyway, and dividing just makes it bad, but we tried. But if you distribute, now it still looks nasty in your heads. Remember, if this was a nice number like 2x, and if this was a nice number like x, what would we do to put them together? Move them all. I can do that over here also. Now, I know it's hard because you don't know what this number is and you don't know what that number is, so you don't know how to put them together as easily as 2x minus 3x. But what you can do is say, but they both have an x. They both have an x. So you can factor, and as soon as you factor, the x is finally all in one place. Divide. Oh, you guys are so funny. Dun 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 dun. Oh! It's not magic. It's the quotient property. Pause. Pause. Did you have to make it all nice and pretty with the quotient property? No. All you needed to do was to get a decimal that would match. And guess what would have matched just fine without needing to simplify? Few of you were like, wait, my brain can do that. Sweet, but both of them are right, and they'll both get the same decimal. What's wrong? Yeah, that's okay, though. That's the thing in homework. Get a decimal, and you would get a decimal, and it would match that one, and you're like, fine, forget it. I don't care. Done. Is that cool? Now pause. What was the key? And if I were you, I would grab the color pen. The key was the distribution. When you had x's and the key was the distribution, and to be honest, I would say getting to one side and factoring. I would say the key is distributing, and maybe some of you need to say, well, the key is first, okay. And realizing that you don't have to be scared of the bases not matching. It's okay. Power down, distribute, get all the x's to one side so you can factor and you'll be fine. Power down so you can distribute. Get all the x terms to one side so you can factor and you'll be. Now pause. What level did I say this problem was? That's why I did not give it to you in the back of your homework spiral to do on your own at the beginning of class. But now, do you have a nice little example to use if something like this shows up in homework? Good. But it's hard to see, right? And I only know that it's hard for you guys to see because, well, I've taught Precalc for a few years, and it's always hard to see. It's not just you. So don't feel like, if only I could. No. It's hard every year for kids to see the distribute. That's why I let you kind of trial and error it for a while and realize the things you're thinking would be so much better aren't so much better. This is the way to go. Hey, no. That's another hard one. Hold on. Pause. Whew. Go do an easy one. Go. It's coming, Matthew. Just hang on. What do you mean? First step. Oh. Because you were hoping the E and LA cancels out straight, right? You're talking about this, right? Oh. It's not a power. That's why we have to talk about it. Hold on. Wait, you guys are going, right? Yeah. Did you read your steps in your notes where the steps said isolate the logarithm? Read the steps in your notes where the first step is to isolate, aka get the log by itself by maybe subtracting and dividing. Did you get ln alone?
Oh, no yet.
Yeah, it's not a pretty number, but keep going, Selma. Divide, yeah? Equals. It's okay, just write it. 10 over 3. Yeah, it's okay. Perfect. Who knows what 10 over 3 is? I don't know, 3 1/3, 3.333. Just write 10 over 3. It's okay, we're not scared of fractions. If you don't know, I don't want yellow. Okay, don't go to decimals. Stop. Write 10 over 3. So much easier. Are we good so far? The logarithmic portion is now alone, with no extra coefficients, with no extra addition, subtraction, multiplication, division. Lord, real. Shh. So, she's awake though. Subtract the 2, divide the 3. Subtract the 2, divide the 3. Are we okay? LN's alone. Tyler, what's up? If I had, oh, like the last problem, right, where there was a place where I couldn't, I just erased all that work. You know how Matthew said at one point, take e to both sides? And I was like, we can't. If there was something in between, I can't just ignore this because it's, so I had to power up e and ln next to each other. But in this example, it's a little different as far as me being allowed to deal with them, because the 3's just, it is a times, it is a multiplication. So you're allowed to divide. There's nothing that I'm trying to like skip over the 3 for. Because I couldn't just skip over the 3 because it needs to go back up. If I'm going to take away the ln, I need to remember it was an x cubed. But the ln's staying. It's okay. So since there's a multiplication, just divide. But we need to get to x. E to the power. Jordan, is that what you were thinking? Perfect. E to the power. And what's e to the ln do? And I have e to the 10/3. Which is what? Box it. You're done. It'll be the right decimal. You're fine. Yeah, rewrite it all sorts of different ways. You could make it the cube root of e to the 10. Make it e cubed to the cube root of 3 1/3. You could make it e to the power of 3 1/3. You could make it e to the 3.3333. But that's fine. Why do any of that? Whew! Back to a hard. Back to a hard. If you have a colored pen, if I were you, I'd put a star next to this one. This is another hard. It's not quite the same as the other one. Some of your brains are going to be like, not bad at all. Some of your brains are going to be like overload. So I'm going to show how to solve it 2 different ways. I'm not going to go the fast way first. Well, maybe I should. Maybe I should go the fast way first. There's completely in your brain no comprehension as to why the fast way is working. It's okay, I'll show you why in just a second. So at this place, we would do this. Okay, this is the fast way. But remember I said, if your brain doesn't see why, I'll explain the other way. You can factor a quadratic with e to the x. Remember how just a second ago I took the ln of 2 and the ln of 3, if it'll let me go back. Remember just a second ago how these A's and B's, and then I wrote down A and B, and then we put in actual numbers to the spot to let your brains process a little bit more why I was going to distribute? Remember that? I'm going to do the same thing here, or at least a similar thing here. A lot of you were like, I don't know what's going on. So let me show you. What if we were to take e to the x and say, you know what, you're messing everybody up. We're going to make you a variable to make it look prettier so we can see the math ignoring you for just a little bit. Okay? So to ignore the e to the x, we'll say, okay, let's go ahead and name him u, because u is one nice letter. There's no weird stuff going on. But here's the trouble. This part's easy. Minus 5u plus 6 equals 0. We can just plug in u for e to the x. That's easy. This is what's hard. Unless you realize, Joe, you're right, but let me show them why. Unless you realize e to the 2x is the same thing as e to the x squared. Pause. What happens if you raise a power to a power? You multiply. But you'd never write x2. That's awkward. You would write 2x. So this is really just an e to the x that's been squared. E to the 2x is just an e to the x that's been squared. So I can technically look at this entire problem as just being a quadratic. And with all quadratics, we have to factor, right? And when we factor with the x, like I showed on the other side, we'll end up with this. We would end up with u is equal to 2, or u is equal to 3. But here's the dilemma. I wasn't wanting u. I was wanting, you should have been wanting x. Huh? Wait. Who is you? Ah. So all we have to do to finish the problem is just plug in e to the x and get back to where we started, which is the exact same place you would end if you figured out how to go straight for the factoring. Either way, you end up with e to the x equals 2, e to the x equals 3, factoring the hidden quadratic that just happened to have an e to the x in its spot, it meaning the variable's spot. And once you get to this spot, you have to say, well, the only thing that undoes an e is an ln. The only thing that undoes an e is an ln. And once you take ln of all the different sides, the exponential is going to simplify or cancel out. The ln is stuck with the 2, and then the e is going to cancel out, and the ln is stuck with the 3. Dun 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 dun. Questions are dumb. But if you were able to answer it, that's good. And if you weren't able to answer, okay. Thank you for realizing that. So this was quadratic, and if you ever see, and you can actually make a note of it, you can put a highlighter mark and say, you know what, anytime you see an e to the 2x with an a plus a b with an e to the x plus a c, anytime you see this, you could always just like that. Could say, if I ever see something with an e to the 2x and something with an e to the x and something with a constant, just go factor it because it's a quadratic. Okay, fine, I'll do it. Or you could say, make it a procedure that you use where you're like, I don't like e to the x, I'm going to use u. Hey, I'm going to factor, and then I'll come back to e to the x. I have to limit it'll solve. Both ways work. It's a bit faster, but it requires a bit deeper level of understanding as far as noticing what's going on. The other way, you get to kind of ignore the yuckiness for a bit and then come back to it and finish. Is there anything that I can try to explain a little bit better for you guys? Jordan?
So I get on the right side of that one you did,
Okay.
factoring and getting that answer, like that makes total sense.
Okay.
I just don't know what is going on with 2, because I don't, where does he go? He just,
What do you mean? I added 2 to both sides. Is that what you mean? Oh, you know what might help? Here you go. The easiest way for you to explain it, Jordan, is to show you that it works. To show you that it works, I'm going to have to FOIL. Check it out. E to the x times e to the x, right? Outer, minus 3 e to the x. Inner. See? The 2x got split up into 2 e to the x's. Because x plus x. Just like if you have factors, the squared disappears, the 2x disappears for the same reason. If you ever had an e to the 2x and an e to the x in a number, you can always factor. The numbers might change, but yeah. Hey, we're done with section 3.4. Whew, we got there. And we went over some of the tricky medium and hard ones in homework, at least the medium and hard types in homework. So as promised, we are going to just introduce 3.5. And believe me, the more we can spread out 3.5, the happier you will be. Okay? Yeah, that's okay. I'm just going to unveil it all. In 3.5, in some ways, in all of section 3.5, you're going to be given a lot of different scenarios where you have to identify what equation to use. If the question is a big old paragraph word problem, they'll probably give you the equation. If the problem is in a table or a chart or a graph, you're probably going to have to figure out the equation yourself. But at the beginning of class tomorrow, I'm probably going to have you guys write down the different ones to choose from so that you're not going blind. Once you figure out an equation to use, step 1, you're going to have to figure out what are all the different variables. A's and T's and R's, and R is the rate, T is time, A is the initial investment, A is the amount of money you have after T years. So you're going to have to figure out what are all the different variables, who are the key players. And step number 3 is going to say in every single equation that you're going to see in 3.5 that comes from different branches of finance, physics, of chemistry, of there's going to be some sort of exponential, there's going to be some sort of log, and you're going to have to prove to me that if or when you ever face it, you'll know the math to solve. But we'll work together on it tomorrow. Bust out 3 minutes. You don't have to face word problems yet. Play with the math.